This is an in-order traversal. In means between. What is between? The node is between the left child and the right child. So first the left child, then the node, then the right child. So we started the root. We want to write down the 23, but I can't because it has a left child. So see, I can't write down the 2 before I do the 1. So I'd like to write down the 16, but I can't because it has a left child. I'd like to write down the 6, but I can't because it has a left child. And that has no children, so that's the 1. I write down the 4. Then I go up to the parent of the 4, so that's the 6. And now I've done the parent node, I can do the right child. So then I can do the 9. So 4, 6, 9. And this now completes the left child of the 16, which means I can now write down the 16, and then I write down the right child, or the subtree rooted at the right, and that's the 20. So that has completed the left subtree of 23. So now I write down the 23. Then I go right, because that's the node. Now I go to its right, like the number 3 in this diagram here. So now I go to the 42. But the 42 is a parent node, so I need to do its left child. The 27 is a parent node. I need to do its left child, which is null. And then I can do the 27, and then I do its right child, the 30. That completes the left child of 42, so I can write that down next. And then its right child, 89. So again, can't do 23, go left, do its left child, can't do the 16, can't do the 6, end up at 4. So 4, and then its parent, 6, and then its right child, 9. Then the parent, 16, then the right child, 20. Then the parent, the 23, and then the right child, 42, which I can't do until I've done its left child, 27, 30, 42, 89. And if I look at this, I see that it is sorted. An in-order traversal gives you your data sorted. This is the pre-order traversal of this binary search tree. Pre-order. We need to remember what pre means. Pre means before. What before? The node before the children. So I've made this little diagram here for you. First the node, then its left child, and then its right child. So let's look at this binary search tree. First the 23, and then its left child, the 16, and then its left child, 6, and its left child, 4. Now at this point, that 4 is like this number 2 here. That 4 is the left child of the node 6. So after doing the left child, I need to do the right child. So after the 4 goes the 9. And that completes the left subtree rooted at 16. Which means that after I've done the left, I then get to do the right. So then I do the 20. And this has no left and no right children. So that completes the subtree rooted at the left of the 23. So now I do the right. So now I do the 42, and this is a node. Then I have to do its left child, so I do the 27, but that's also a node that has no left child, but then a right child. So after the 27 goes nothing, and then 30. And this completes the left subtree of the 42. So then I do its right, which is 89. So 23, 16, 6, 4, 9, 20, 42, 27, 30, 89. And that is the pre-order traversal. This is a post-order traversal. I need to remember that post means after. And some people get mixed up between pre and post. It's easy if you can remember the pre-game show and the post-game show. Pre is before, post is after. So in this sense, what is after? It is the parent node that is after the left and the right. So according to this little diagram here, first the left child, then the right child, then the parent. So I want to write down the 23 because I will start at my roots. I want to do the 23, but I can't because first I've got to do its left child, and first I have to do the 16's left child, but first I have to do the 6's left child, which doesn't have any children, so that is the 4 that comes first down here. The first number I write down is the 4. Having done the left child of 6, if I go back to this diagram here, I need to do its right child. So then I do the 9 and then the 6. So if I look here, the 4 and then the 9 and then the 6. And this completes the left subtree of the node at 16. So then I have to do 16's right, which is 20, and then I can do the 16. And this completes the left subtree of my roots. But then I can't write down the root yet. I have to do its right subtree, so I have to do this one. But I can't do the 42 before I do the 27, which I also can't do before I do the 30. So 30 and then 27, that completes the left subtree of 42. Then I need to do the right subtree, which is 89, before I can do the 42, and that completes the right subtree of my roots, and that is the last thing that I can write down, my 23. So again, go left, go left, go left, 4, 9, 6, finished the left, 20, 16, finished the left, go right, 30, 27, 89, 42, and finally 23. And that was your post order traversal.